So this next section broken into a couple different parts because it's very, very important that you guys know how to factor. Some of you guys are still having trouble and you've forgotten it from Algebra 1. How many of you guys have forgotten how to factor? It's okay. It's about half of you. It's okay. So we need to learn it now because you do use it in every single math class, so you need to know how to factor right away. All right, so there's lots of different ways that you can have factoring. So I'll kind of run you through the different types. Okay, so it says, as you know, numbers can be factored until you have only the product of prime numbers. So this is called prime factorization. So with numbers, if I had 100 to start out with, do you guys remember how you did this back in like elementary school? You broke it into 10 and 10, and then you did 2 times 5, and then 2 times 5, right? So it would be 2 squared times 5 squared for prime factorization. Okay, that's basically what we do with polynomials as well. We try to get it into its prime factors, so where each one can't be factored anymore. All right, so the first type is if we had any number that we could pull out. So this is a factoring technique called greatest common factor. So this is when they have some kind of number or variable or something in common. So when you look at the first example, okay, do they have any numbers in common? No. The last two have 2. But the first one didn't have a 2. So there's no number. What about variables? A, so just a to the first. Yep, because this one just has a to the first in the middle. B squared. Do you guys see how all of them have b squared? Any c's? No. So we can pull out a, b squared because they each have a, b squared. Okay, so it's kind of the opposite of what we did before. Remember when we multiplied a monomial in and we got the new powers? So now we're pulling it out. So we say, what would we need in the first spot to multiply by a b squared to get a cubed b squared? So you guys see you need an a squared. So that would give you a to the third power, b to the second power, if you multiplied it in. Okay, in the next spot, I'd need a 2. I have a, as I already have the a. B squared, I already have the b squared, so I just need c. Minus 4. I already have the a, I already have the b squared. So that's it. Oops. So it's a squared plus 2c minus 4. Yes, Andrew?
So why did we do that?
Why did we do that? It's the opposite of multiplying it in. Do you remember how we multiplied in, and when we did that we got a cubed b squared plus 2a b squared c minus 4a b squared. So you can kind of check it in your head to make sure it's the same thing.
So it's just doing it the opposite way.
Mm-hmm. Yep, and this is going to be useful in a lot of like real life problems. So if we like throw a ball into the air and we want to find when it hits the ground, you would have to factor things to figure that out. Why would you want to know that? So if I launch a rocket into space and then it comes back down, you'd like to know where it lands, right? That'd be good. Okay, so number 2, difference of 2 squares. So if I have x squared minus y squared. Okay, so if you factored, or if you FOILed, you know you need x times x to make the x squared, and you need y and y to make the y squared. And there's no middle term. So this is plus and minus. So do you guys remember how to FOIL? So first, outer, inner, last. So let's check. So my first terms make x squared. My outer term makes negative xy. My inner term makes plus xy. And my last terms make negative y squared. Okay, so that's why you have to have opposite signs in the middle, the plus and the minus. Because now you have negative xy, it cancels with positive xy. That's the only way you're going to get 2 terms like that. X squared minus y squared. Okay, so let's try the next one. Okay, the difference of 2 cubes, we're going to talk about this a little bit more. And same with sum of 2 cubes, but here's how it's going to factor. You're going to have a minus b times a squared plus ab plus b squared. And sum of 2 cubes is going to be a plus b times a squared minus ab plus b squared. Okay, so again, we're going to talk about that in a little bit, but I always remember that their signs, see the original signs was a minus, So this was the same, then this was a different, so it was plus, and then the last one's always plus. So see how that works for the bottom one as well? Same sign, different sign, plus sign. Same, different, plus. Okay, the next one is called a perfect square trinomial, because when you factor it, you need that x and the x to make the x squared. And you need the y and the y to make the y squared. And then you're going to have plus for both of them. So you can check by foiling. So x times x is x squared, so that's first. Outer is xy. Inner is also xy. Last is y squared. So see how you get x squared plus 2xy plus y squared. Okay. It's called a perfect square trinomial because you have x plus y times x plus y. In other words, you have x plus y squared. So that's what we call a perfect square. It's something square. Okay, general trinomials are the ones that are scary for people. So general trinomials are just in the form ax squared plus bx plus c. Okay, and you have to think about the opposite of foiling. So your first spots are the spots that made x squared. So if your first spots make x squared, and we want them to be 2x squared, what are two things that multiply to be 2x squared? What? 1 and 2. So we need 1x and 2x, right? So I put 2x and 1x. That's what's going to make 2x squared as I'm foiling. So the first spots are always the spots that make the x squared term. Okay, these last spots are just your plain numbers. So what number do they need to multiply to be? No. No, what should I do? Oh, -2 and -2. Did you say -2 and -2? Is that what you said? I thought you said -22. I was like, what? Okay, so so -4. So see how they need to be this -4? So Kernstein tried 2 and -2. Because they need to multiply to be that -4. Do you guys see why they need to multiply to be -4? Because these are the number spots. These are two numbers that are going to be multiplied together for the last term. Okay, so you can try 2 and -2, but what happens if you put a 2 here? There's tricks that you're going to learn when you're factoring. You can't put a 2 here because then they have a 2 in common. And if they have a 2 in common at this step, they should have had a GCF in the first step. Did they have something you could pull out in the first step? Were they all divisible by the same number? No, they weren't all divisible by 2. So we cannot put a 2 there. We also can't put a 4 there for the same reason, because then you could have pulled out a 2. So what's the only number I can put there? A 1. So that means you put a 1 here and a 4 here. And then I always check my outer and inner. So my outer is 8x and my inner is 1x. And I think, is there any way I can combine those to get 7x, the middle number? Yeah, if I subtract the 1 and make the 8x positive. So that means I need a -1 and a +4. And that's how you factor that one. So it should be 2x minus 1 times x plus 4. So we're going to do a ton more examples, so it's okay if you don't understand right now. Okay, and then the last method we're going to talk about is the grouping method. So the grouping method I always call split the middle. Okay, so you literally do that. You just split it right down the middle. Make sure the sign is on the right side. See how the sign goes with what it went with before. So -2x. Okay, then you just do the GCF method on each piece. So on the first half, so on the left half, you have 3x squared plus 3x. So what did those two pieces have in common? A 3 and an x, right? So I have 3x. When I pull that out, I have an x plus 1. I need the placeholder. See how, think about multiplying it back in. If you didn't have that plus 1, you wouldn't have that second term. A lot of people will just put x there. It should be x plus 1. Okay, now in the next part, what could I pull out from the next part? 2. And I want to have exactly the same thing that I have here. So if I have x plus 1, I want to have x plus 1 over here. So not only am I going to pull out 2, but I'm going to pull out its sign as well. Do you guys see negative 2? Okay. Here's my question. If I had 3xy minus 2y, how would you factor that? What do they have in common? A y. Did you guys see that? So you just pull a y to the front, and you'd be left with 3x minus 2. That's exactly what we're going to do on this next step. But it confuses people because it's a whole term. It's like that whole x plus 1 is all together. So see how they both have x plus 1 in common? You're going to pull it all the way to the front. So when you do that, you're going to have x plus 1 all the way in the front times what's left, the 3x minus 2. And then that's fully factored. Okay, scary. Okay, the big thing on the factor by grouping is that some people write x plus 1 squared, like they'll put a squared there, because they're like, oh, but there were 2 of them. But you didn't put a y squared here, did you? So that shouldn't be a x plus 1 squared either. You just pull out what they have in common. What they had in common was x plus 1. So you pull it to the front. Okay, so let's do a lot of examples. Okay, so the first one, so I have factor 10a cubed b squared plus 15a squared b minus 5ab cubed. So your first step is you always look for greatest common factors. So you always pull out GCFs first. Okay, so in number 1, what do they all have in common? So let's start with the number. So what number do they all have in common? 5, yeah? Yeah?
5AB.
5AB. Do they have any more A's? No? Because the last one only had 1A. Any more B's? No. So it's just 5AB, right. So I'm going to pull out 5AB. And when I do that, think about what you would need inside to multiply to B each term. Do you see what I'm saying? So it's like you're dividing by 5AB in each place. So I need a 2. I need 2 more A's, so A squared. I need 1 more B, so A squared B. See what I'm doing? All right, plus 3A, no B's, minus 1. You can write 1 if you want, or just write minus. A's, we don't need any more A's. We need B squared. So that's that. Okay, that's your answer. Make sense? Okay. Let's try one factor by grouping. So let's do number 2. So on number 2, I'm going to split right down the middle. On the left side, you're going to pull out what they have in common. So on the left side, what do they have in common? X squared. So I pull an x squared out. I'm left with x minus 6. So again, you're thinking about what you would need to multiply in. So you need x minus 6. On the other side, I know I want to have x minus 6 left. So is that possible? Is there anything you can pull out to have x minus 6? 2. So plus 2. Okay, now we're at that point where they have the x minus 6 in common. So again, you're thinking of it in your head as x squared times something plus 2 times that same something. You pull out the something. So pull out the y. You'd have x squared plus 2 left. So in this case, we have x minus 6. So I'm going to pull out the x minus 6 and write it out front. And then I just write what's left, x squared plus 2. You can always FOIL it out. You would end up with the same thing that you started with. So that's your answer. Okay. Class is noisy. All right, I think we still have 5 minutes. I think it's an E day today. Yeah. All right, so go ahead and try number 1. So try 1. you should pull out x squared and have x minus 1 left in the beginning. Do you guys see why it's x minus 1? You need that, I always call it a placeholder, because if you multiplied back in, you'd have x cubed minus 1x squared. If you don't have the minus 1, you don't have that first half. Okay, what can you pull out of the second part to have x minus 1 left? Negative 25. So when I do that, I pull the whole x minus 1 to the front, and I have x squared minus 25 left. Now this one's not completely done, because now I have x squared minus 25. And do you remember when you have the difference, so a minus sign, of two perfect squares? So x squared minus 25 is x times x and 5 times 5. So the difference of two squares, you can factor it further. So how can I factor x squared minus 25? Yep, x minus 5 and x plus 5. Those are the ones where if you had FOILed it out, the outer and inner terms cancel each other out. You have 5x minus 5x. So that's why there's no x term. There's no middle term. And that's your final answer.